Perfect. Well, I'm excited to be here tonight and able to virtually present with all of you. I've been at PMI now for about a year. And as you mentioned, CPMAI is the fastest growing certification at PMI volume wise, not largely. PMP is still number one, but it is a very fast growing certification. So I'm excited to talk to you all tonight about what I've seen over the past about 9 years that I've been in this space and what that means for you. You may have heard this statistic, 80+% of AI projects fail. And when you see the statistic, you go, wow, that's huge. Like, I understand I'm not going to have, 100% project success, but 80% of AI projects fail. And we said, why? Because there has to be reasons for why they fail. And what can we do about this? So like I mentioned, I've been in this AI space now for almost a decade and said, let's look at common reasons why AI projects are failing. And then what can we do about that so people can learn and not make these same mistakes? So the first failure reason that we've seen is that AI projects are not like traditional software development projects. So if you think about if you've run an AI project at your organization and you approach it the same way you approach traditional software development projects, you're going to quickly realize that they fail. And you can go, well, why do they fail? Well, when you think about software development projects, code is going to be the most valuable part of that project. And the data is important, but not that important. With an AI project, your data is the most important part of that project, and the code, not so much. So if you understand that AI is all about the data, then you say, okay, data obviously is going to be so critically important, but where do I even begin to say, is this something that's an AI project? Does this look like a good AI project? Is this not? And especially a few years ago, people were getting really tripped up on terminology. So we said, let's take it one level deeper and let's not focus so much on, is this AI or is this not AI? But let's focus on what we're trying to do and really drill down one level deeper. So we looked at hundreds, if not thousands, of different use cases and found that they all fell into one or more of these patterns, which we've named the 7 patterns of AI. And it's presented in a wheel because no one is more important than the other. So if we're thinking about, is this an AI project, we can say, all right, breaking it down, presenting it, like I said, no one is more important than the other. So we'll start with hyper-personalization, where we're treating each individual as an individual. No longer do I bucket you into groups or categories, but I'm able to treat each person as an individual. We think about this as a marketer's dream, right? I'm able to reach the right person at the right time with the right message. But we can also have hyper-personalized education or hyper-personalized healthcare or hyper-personalized finance. There's no way that we'd be able to do that at any sort of scale if we didn't have AI. Then we have the recognition pattern. This is making sense of unstructured data. I like to think about image recognition in this pattern or facial recognition, right? You can't program or code your way to identify each individual person's face. So if we have a lot of unstructured data, we need to make sense of it. That's a great use case. Then we have the conversation and human interaction pattern of AI. So this is where you have humans and machines interact with each other in the language of humans. So we think about AI-enabled chatbots in this application. Also think about prompting in this application as well. Then we have predictive analytics and decision support. So this is where you take past or current data and help humans make better decisions. The human's not removed from the loop in this. So I always say it's a great pattern to start with if you have, applications that you can do here because the human isn't removed from the loop. Then we have our goal-driven systems pattern. So this is really around reinforcement learning and finding the most optimal solution to a problem. We think about game playing or scenario simulation. An example I always like to use here is that the city of Pittsburgh used their goal-driven systems pattern to optimize traffic lights so that they could reduce idle time and congestion on the road. Then we have the autonomous systems pattern. So the goal of the autonomous systems is to remove the human from the loop. Whenever we're removing the human from the loop, it's obviously going to be incredibly difficult. So I normally say, don't start with this pattern unless you have to. Whenever I think about autonomous systems, I always think about the, hardware systems, right? So vehicles or robots, but we can also have autonomous software systems as well, where they can automatically navigate through your environment. And then last, we have patterns and anomalies. So machines are really good at looking at large amounts of data and being able to spot patterns and trends in that data or spot those outliers or anomalies in that data. A good example I like to use here is fraud detection. It's really hard to code your way to fraud detection, right? You have to look at the data and learn over time. So it's important to understand also that AI applications don't function based on their code. Like I said, it's all about the data, and not all AI projects are the same. And so when you think about the data that you need, the algorithms you're going to select, how you're going to be building these systems, the time to ROI, that will depend on and vary based on the 7 patterns of AI. The next failure reason that is a common reason we've seen on many projects is that the ROI, that return on investment, is not justified by your project. So whenever you think about any project, right, any project that you do at work, there's a cost associated with that. So you want to make sure that the cost of your AI project, and I always say this is money, time, and resources, that the cost is less than the return. And this sounds simple, right? I mean, this is very basic. I know all of you here, project managers, say yes, of course. But when it comes to AI, people get very excited and move forward without always really measuring what that return on investment is going to be. And before you know it, you've spent a lot of money and don't have much to show for it. People always like to fall in love with AI until they don't. So when we think about these projects, we always have to say, why is the project started? Phase 1 of CPMAI methodology is phase 1, business understanding. What problem are we trying to solve? Make sure that we're solving a real business problem. Then make sure that AI is the right solution to that problem. If you don't know if AI is the right solution, go back to the 7 patterns of AI and say, does that fall into one or more of these 7 patterns? If so, it's a good use case. If it's not, probably not. One thing that you did not hear me say in the 7 patterns of AI was automation, because automation and autonomous systems are not the same. Automation is repeating something over and over. So we think about an assembly line, right? We have a robot that, is programmed to do the same thing every time. Incredibly useful, but not intelligent. So you don't need to have an AI system if you're just going to be programming your way or have an automation. We also, like I said, want to make sure that we have a real purpose to this project. Many times people feel FOMO, they want to go ahead and move forward with something, and then they do, only to realize they've invested all this money, time, and resources to not really have a great solution. So an example that I like to give is Walmart is a very forward-leaning company. They have a large R&D department, and they invest heavily in AI. A few years ago, they decided that they were going to have robots that scanned the store shelves and were able to look at inventory on the shelves and then be able to see if things were misstocked or out of stock. So if we think about that, the robot autonomously roamed the store floor and was able to look at items. Which patterns do we think of AI were being used here? One, the recognition pattern, because we're making sense of items, right? We're identifying items on the shelves. And then the autonomous pattern, because the robot is navigating the floor on their own. Well, I just said earlier that the autonomous pattern is the hardest pattern to start with. So what Walmart could have done is said, let's break these patterns apart. And we at Cognilytica, which was acquired by PMI, and now at PMI and also for CPMAI, say, think big, Start small and iterate often. So what Walmart could have done is said, why don't we just have a camera that can sit on a shopping cart that we already have in the store and a human that's already in the store and push it up and down the aisle. And if we wanted to control that scope even more, we could say, let's start with our most problematic aisle and get that right and see what that return on investment is before we move to the next aisle and the next aisle. And then if this proves to be such a great success, we'll have this autonomous robot. So that's why we always say, make sure that you understand what your ROI is and measure it. Well, we talk a lot about data, right? Data is the heart of AI, and I've said this now a few times. So it should come as no surprise that data quantity and data quality issues are common reasons why AI projects fail. And this, a lot of people say, well, how much data do we need? And the short answer is, it depends. Now you're going to go, but Kathleen, you just said data quantity is what we need. So isn't more better? And again, it depends on what pattern of AI we're using. We don't always need large amounts of data, but we need to make sure that we have enough data that it can train on the system. And then we have to have that good quality data so that we're not training on bad data. The old saying, garbage in is garbage out, applies to AI. So we like to have these ripped from the headlines news articles because if large companies are doing this, then small companies and maybe your company will also fall into one of these traps if you don't learn from others' mistakes. So a few years ago, in December of 2023, Rite Aid was actually banned from using AI facial recognition technology for 5 years after it was discovered that they were falsely tagging customers as shoplifters. And you can go, well, that stinks for Rite Aid, but also learn that as a cautionary tale, right? What were some of the problems that caused that? And now their competitors can use it and they can't. So what caused this was they were using images from their, closed circuit TV cameras. Well, as you can imagine, that's going to be pretty bad with data quality, right? I mean, they're normally black and white, they're grainy, they're not always at the best angle. And who knows how much data they actually had to be training these systems. So they had an issue when it came to data quality, and as a result, did not have good outputs. Also, we've seen it when it comes to data sets. So sometimes you're going to get third-party data sets for a variety of different reasons. Maybe they already have good, clean, well-labeled data. You're going to use it for, to speed up time so that you don't have to get these images labeled yourself. But be careful, because you don't always know the quality that's in that data as well. So MIT Technology Review a few years ago let us know that ImageNet data, which is a huge data set, was actually warping our sense of how good AI really is. And you don't always know that this is an issue until it becomes an issue. So the image that we have here is an image of a deer, but it's being labeled a magpie, which is a small bird. And again, you may go, well, that's okay. I don't have images of animals at my organization that I need to label, so no big deal. But this was just one example of an issue that was mislabeled. So you have to make sure, and you don't always have these insights, especially if you're using third-party data sets, as to what caused some of these, or just how good or what is mislabeled. So data quality and data quantity are both very important issues when it comes to AI projects. And a few years ago, we did a report and found that about 80% of AI projects are really data engineering projects. And so if you think about the time spent on a project, and especially with CPMAI, we like to work in iterations. So we have 6 phases for each iteration. We start with phase 1, business understanding, then we go to phase 2, data understanding. We want to make sure we understand what data we need, the sources that it's coming from, if we have access to that data. And then we go to data preparation. Those are the 3 just the first 3 phases out of 6, but they take up about 80% of each iteration's project time. So that's important to understand from a timing perspective for your projects and also from a resource perspective for your project. So if 80% of your AI projects are data engineering projects, you're probably going to want to weigh a little bit heavier on your data engineers than you are data scientists, if that's how you split in your organization. The next common reason that we see why AI projects fail is this idea of the proof of concept trap. And it's easy to get into this trap. I actually was just talking to a friend of mine about a week ago who has an AI tool that he's building and wanted to get my feedback on. And what he's doing is he's built it and now he's testing it. So when you have somebody who's built the product and knows exactly how it should be used, and then you're testing it, you're just living in that nice, clean sandbox environment, right? You're probably giving it the best data, you're using it in a predictable manner. But then when you put it out in the real world, people don't use it as expected. And this is the proof of concept trap. So we say always, always, always get out there in the pilot, in the real world, have people who haven't built it, who aren't so close to it, use this product and have it be used and tested on real data. That's the only way to see how things are going to actually work. When I went in and it was a chatbot feature to the solution, I went into his tool and I, asked it a question that he goes, "Wow, I wasn't expecting you to do that. You jumped right in. I thought you were going to, prep it a little more." And I said, "No, but you don't know how people are going to use it unless you actually get out there and have them use it." That's why it's so important to always go to that pilot. And if you have a proof of concept, you're really just going to prove nothing and build it out in your little sandbox environment. And then when it goes to the real world, it may fail spectacularly because you weren't able to understand all of these different issues. Another common failure reason is that the real world doesn't match your model. And you'll notice that all of these failure reasons, they're not independent of each other, right? You can have multiple failure reasons for the reason why your AI projects fail. So that's why it's important to understand all of them and then try to avoid it. So what we found is that when you want to, Silicon Valley, the tech industry, they have this idea of move fast and break things, right? Just move fast, just get it out. But that doesn't actually work when it comes to AI because the real world is a lot more variable and messier than your training data, than getting out there. And also, you're not able to maybe move as fast as you'd like. Even though we say your sprints should be, each iteration of your CPMAI project should be only a few weeks long. So this is why it is so critically important to really get out there and make sure that you're testing on real world data. Make sure that you understand what your real world environment is, what your users are, what the machines are that are going to be out there, or whatever that environment is. So for here, Andrew Ng is an AI luminary. He's been in this space for a long time. He's a great mind. And this IEEE article had an example that he shared where at Stanford Health, they were using a radiology AI system to look at different images that came out of the machines from Stanford Health. And it was able to do a great job. And then they said, okay, this is great. Now we want to bring it to additional hospitals. And what they found out is they said, it turns out that when you take that same model, that same AI system to an older hospital down the street with an older machine, and the technician uses a slightly different imaging protocol, the data drifts to cause the performance of the AI system to degrade significantly. In contrast, any human radiologist can walk down the street to an older hospital and do just fine. So you have to take this in and say, what are some of the lessons learned here, right? So I don't make the same mistake. Maybe I don't have radiology images, but maybe I work at a multinational organization and we have data from one part of the world that might look different from data from the other part of the world. And have we trained our models on both of that data? Are we making sure that we're representative? And maybe our data is changing. Maybe it's seasonality. So make sure that we're training it on that data that it needs to be trained on, or if we have customer service agents and each of them answer things just a little bit differently, or there's local colloquial language that we need to take into account here. Make sure that we have all that, right? So we can see that there's data issues coming into play, maybe the ROI, make sure that that's justified. The real world doesn't always match your models. Don't go into a proof of concept, go right to a pilot. Maybe they could have incorporated a few different hospitals and all of their images. Or what they could have done is said, let's not start with the best quality images that we know we have from this state-of-the-art hospital. Let's start with the hospital down the street that uses an older machine. And maybe let's test it on multiple technicians, because if they all have slightly different imaging protocols, then let's make sure that we get that nice representation. We've also found that AI project life cycles are continuous. The worst thing that you can do is set it and forget it when it comes to AI. You need to make sure that you understand the life cycle of these projects, that you can't build it and then set it out into the wild and never monitor it ever again, never retrain these systems. And also, don't set aside resources for this. So this can be financial resources, maybe this can be machine resources, maybe this can be people resources. You really have to think about that. Because we said earlier, right, AI systems are trained on data. And guess what? Data continually changes. And depending on the environment that you're in, it may change very, very frequently. We see that data drifts over time, data can decay over time, and models will do the same because they are trained on data. So models' performance will drift. You may train your model and initially it's performing at 98% accuracy, and over time it degrades. You're going to have to retrain your models. So failure happens here not at the initial phase when we put out this nice new model that we've trained and is working great, but failure happens when we don't budget that time or resources for AI model maintenance, or we didn't account for bad things to happen when models drift. So again, we like to have rip from the headlines. And about a year ago now, Air Canada got in a lot of trouble. They were taken to small claims court and actually lost because they decided that they wanted to put a chatbot onto their website. So, large language models are out. People are super excited. They're like, this is going to be an easy win. We're going to get a chatbot on our site. It's going to be able to answer a ton of different questions for our customers. We can set it and forget it, and we can move along and now say we have a chatbot. Well, a customer came and they had a bereavement in their family. And so they went into the chatbot on Air Canada's website and said, what's your bereavement policy? Got the policy from the chatbot, took a screenshot, went and booked their flight. And then when they went to claim the bereavement policy, Air Canada said, that's not our policy. And the customer said, but your chatbot told me so. And they said, oh, well, yeah, the chatbot may have said that, but the chatbot's not authoritative. You have to go to the written word on our website. And so the customer took them to small claims court and lost. So what Air Canada could have done here is they could have done a few things. They could have either had a disclaimer on their site and said, use this to help you with different things, but note that what the chatbot says may not be authoritative. So if you want the most authoritative answer, go to our website or call customer service. Or what they could have done is said, again, think big, start small, and iterate often. They could have said, what's the number one question that we get asked? Let's have the chatbot answer just that. And then we go and think about, well, why do we want the chatbot, right? What problem are we trying to solve? Well, maybe we're trying to reduce call center volume, or maybe we're trying to improve customer satisfaction because people can't find this section of our website very well. So they can monitor that, see how it did, and then say, okay, was my return on investment positive or negative? An example I like to use is US Postal Service did just that. If, as you can imagine, they have a large volume of packages that come out around the holidays, but they didn't necessarily have the budget to hire more people for their call center. So rather than, trying to hire seasoned seasonally and not really being able to fill all these spots, or just having extra long wait times and very upset customers, they said, well, what's the number one question that we get asked? Help me track a package. Let's build a chatbot that answers just that one question. Our goal is to reduce call center volume. We're going to measure how much we reduce call center volume and see how many people are using the chatbot. And they did, and they found out that it was a great success. It was able to reduce call center volumes. People were able to get their questions answered a lot faster about where their package was. They had satisfied customers. And they said this was great. This was positive ROI. Now let's move to the second most asked question, and then the third, and then maybe we'll go to the 10 questions and 20 and 50. Rather than saying, let me put a chatbot on my website that's able to answer 10,000 questions all at once and maybe not do a great job like we had with Air Canada. The failures are a lot more in the news than the successes. New York City famously had a chatbot that they put onto their website, was again to help people navigate through the complexities of their website, but the chatbot started to give wrong and illegal information. That's not something that you want to happen at your organization. So make sure that you learn from others, and chatbots are absolutely great and wonderful, and many people are using them. But think about the questions and the real problem that you're solving when you're putting that chatbot on your site. And you can control the scope, right? Start with just one question or two, and then continue from there. Make sure that you're measuring it. Make sure that it's providing that positive ROI. Make sure that you have the data that you need to train these chatbots, and then you can continue to grow. Another common reason that we see AI projects failing is if you fall for this vendor hype, or there's a product mismatch, there's overhyping and overselling. Far too often, we see organizations say, we need an AI solution. We need something, right? And then they turn to their vendors and say, what do you have? And it doesn't always work that what the vendor has is the solution to their problem. Or you can be in vendor X shop and insert whatever that is, a Google shop or a Microsoft shop or whatever else, right? It doesn't matter the vendor name. And so you're really encouraged to get products from that vendor. And they may have absolutely great solutions. It's just not the right solution for your problem. And things are changing very quickly too. So just about every single time I give a presentation, people always ask me, well, what's the best AI tool I should use? And, what's your favorite AI tools? And I always say, that depends, right? It depends on what you want to use the tool for. A tool that I love may not be a tool that you need. So just because I love it doesn't mean it's a good solution for you. And that's why you really need to understand what problem you're trying to solve, figure out, do a little bit of research, try and get your head around what it is that you actually need, and then you're able to get that right solution. IBM Watson famously went from the future of healthcare to being sold off for parts. They were, again, being very forward leaning, trying to be ahead of their times, get ahead of this. And it failed, unfortunately, spectacularly for them because they just weren't able to kind of find that right fit. And so that's why it's important to make sure, because I always say it's people, process, and technology. And it's really easy to just throw more technology at the solution, but that might not always be the right solution. So again, go back to phase one business understanding, figure out what problem you're trying to solve, and then make sure that the solutions that you have in place help to solve that problem. The next common reason why AI projects fail is this idea of falling into the uncanny valley. So I don't know if any of you are familiar with this term, the uncanny valley, but it's usually for physical objects. And it's when we try to anthropomorphize or make non-human objects more human. So an example that I have here is this cute little toaster, right? And over on the left-hand side, it's this cute little toaster with just a little smiley face. And you're like, that's not creepy. Then we move to, okay, we got a little bit bigger googly eyes, This might be from a movie, right? Okay, it's still pretty cute. It's not that intimidating. But now that face moves to a little bit more human-like, and we're like, oh, that feels weird. And now it's like this toaster kind of has a human face on it. And so now this is making me feel really uncomfortable. And now I've fallen into the uncanny valley. And then up at the end, it's a human, and you're like, okay, I'm okay with this again because you're a full human. Well, the problem with falling into the uncanny valley is that this can happen with data as well. So I like to give this example. Sophia Robot, back a few years ago from Hanson Robotics, was out making the rounds, and they had Sophia look almost human, but not quite human. So you can see her face looks pretty human, but then she doesn't have hair. And so they made the back of her head clear so you could see that it was a robot. Well, you can fall into the uncanny valley with data as well. And so it's important to understand this, especially if you're trying to do the hyper personalization pattern where you're trying to treat each individual as an individual. Because everybody's uncanny valley line is just a little bit different. So you can't say, well, I'm going to build right up to the line and not go over it because everybody's line is a little different. So if you think about recommendation system, for example, maybe you're going to say, hey, I also, I noticed that you're buying marshmallows. I recommend that you buy camping tent and a sleeping bag. And you're like, oh, thanks. I actually am going camping and I needed a new sleeping bag. So that's great. Thanks so much. Or maybe you're buying marshmallows and it goes and looks at your past, purchase history and goes, well, I noticed that you gained a little bit of weight, and I don't think that your pants are going to fit for your camping trip, and you're probably going to need new shoes too. And you're like, wait, hold on. Yes, thank you for letting me know I gained a little bit of weight, but I don't need my machine to be reminding me of this. And then maybe it does something else too, where, 5 days before your trip, it says, hey, you didn't buy those shoes. If you don't order them now, you're not going to have them in time. And some people can go, well, that was great. Thanks for the reminder. And other people go, you're encroaching too much on my space. I can't believe that you checked my calendar and saw that, I needed new shoes. That's too much. And you dip into the uncanny valley. And once you fall into the uncanny valley, it's hard to near impossible to get out of. And unfortunately, because everybody's line is a little different, so you can't just kind of walk up to that line and not really go into it. So that's why it's important to understand this concept and that it can happen, especially depending on what pattern you're trying to do. Now, the big overarching reason why AI projects fail is this idea of overpromising and underdelivering. AI is not a new term, right? It was officially coined in 1956. Yet, we feel like it's been around for just a few years. And that's for a number of reasons. Most notably, large language models have really put AI into the hands of everybody. But we've been here before, and we've gone through 2 previous AI winters, which is a period of decline in investment and popularity and a big pullback from AI. So I always like to call AI the oldest, newest technology, but it's a cautionary tale. And this idea of overpromising and under-delivering on what the technology can do, people get so excited about AI and they get so excited about the possibility, but then they under-deliver on what they actually say they'll do. So we need to ask ourselves a few questions. Why are we using AI at all? Go back to those 7 patterns. Are we trying to solve for one or more of those 7 patterns? Are we promising too much from our AI solution? Like, yes, it's a chatbot, but I also want it to be able to, do this and that and a bunch of different things. I want it to be able to drive my car, and I want it to be able to make coffee for me in the morning, and I want it to be able to, do a whole lot of other things. So make sure that we're not promising too much of the solution. Are we more invested in doing AI than solving the problem? Again, this is something that we really need to be mindful of and make sure that we don't get caught up in the AI hype and say, why are we doing this? And make sure that we understand what problem we're trying to solve. I've said this a few times now because it is so incredibly important, because far too often I see organizations jump in to wanting to do AI without even knowing why they want to do it or what problem they're trying to solve. They say they're doing it because they feel pressured and their competitors are doing it and they want something out in the market. But if you're not doing it to solve a real problem, you're going to run into some of those common reasons why AI projects fail, such as what is your return on investment? When you come to your AI projects too, you really have to think about what pattern or patterns of AI you need, and don't start with the hardest pattern if you can avoid it. So if the goal is to build an autonomous vehicle, then yes, of course, you're going to have to start with that pattern. But the Walmart example, they had two patterns. They had the recognition pattern and the autonomous pattern. They could have started with the recognition pattern, been able to show that it was successful, it was a positive return on investment, it was showing the gains that they were looking for, and then moved to the next pattern. You don't have to tackle multiple patterns all at once. You can break the project down even further. The good news is that AI project success is possible. I talked earlier about people, process, and technology. It's really around the people and the process. And that is what CPMAI does. So it helps us think big, start small, and iterate often. It's 6 phases. You can scan this here. That will take you to the training and certification page. We start with business understanding. What problem are we trying to solve? Then we go to data understanding, making sure that we understand the data that we need. Is it internal? Is it external? Do we have access to that data? Then our data preparation. So once we know what data we need to make sure that the data is in a good quality and state for us to be training these systems. That's those, right? 80% of AI projects are data engineering projects. Once we get to phase 4, now we get to that fun stuff, right? We get to build the model. So this is model development. So if we're building the model, then we're going to be doing algorithm selection here. And then we get to model evaluation. We need to make sure that this is performing as expected. And you don't have to just be building these models from scratch. You can also apply CPMAI with Gen AI solutions as well. You're still going to have to be testing it. So figure out, rather than building the model from scratch, figure out what Gen AI solution you want in model development. Then we have to be testing this, right? These have to be performing as expected. We can't just set it out into the wild. Once we've tested it and made sure that it's working as expected, that's where we can actually set it out into the real world, model operationalization, and use that. And it's an iterative approach, so we can take many sprints here. We have a free Intro to CPMAI course that is now available in 11 languages as of yesterday. Yes, 11 languages. What is the 11th language? Klingon. For anybody that speaks it or aspiring Klingon speakers, I encourage you to check it out. It's a lot of fun. That QR code will take you to the link. And in addition to that, we also have additional resources. All of these are free for PMI members, and 3 of them are free for everybody. So if you haven't taken these, I encourage you to. They're really wonderful courses. Our Gen AI overview is a really solid course. Data landscape is great. Talking to AI teaches you about prompt engineering, goes through a few different prompt patterns. It's a lot of fun. Then we have our practical applications of generative AI, talks you through using different AI tools and different workflows. And then we have our AI in infrastructure and construction projects. So with that, I want to thank you all so much. And I will now check. This is my LinkedIn. Please reach out, connect with me. I post things pretty regularly on there. But with that, now I will leave the rest of the time for Q&A.
Okay, looks like we have a question from Bruce. Must understand how repeatable is the process and the data. Bruce, do you want to come off mute and give us some context to the question, or does that make sense to you, Kathleen?
Is it in the chat? I'll look at it.
Yeah, it's in the chat at 6:43.
Oh, it's in the chat. Oh, okay. Yeah, let me see. I have the chat coming up at 6:43. Okay. So the way that I would take this is the approach is CPMAI repeatable, and what do we do? The data question is the second. So So what I'll say is, yes, CPMAI is a repeatable step-by-step approach. The reason that it came about was that organizations said, this was back in 2018 when we started this too. So I always say this was before Gen AI made it hot. And they said, okay, this is great. We want to get started with an AI project. We said, okay, there clearly has to be something out there already. And what we found is that there was Crisp DM, which was built in 1999, but then never iterated on. And this was before Agile. And this wasn't iterative. And then there's Agile, right? And everybody says, oh, well, we're going to do this. We're going to use Agile. And we go, well, you can run your AI projects in an Agile way, but you're not using Agile to run your projects. So we took Crisp DM and Agile and we added AI elements to it. We made it iterative. And that's where CPMAI came about. And we created this with a large bank and a large government agency in the US. And they piloted it and it worked for their AI projects. So we always say, think about the smallest thing that you can do and do that for each iteration so that you are, continuing with these projects and know that it's not going to be, again, like I said, that set it and forget it. But one other thing that we found is that far too often organizations take way too much time trying to get their data. So there was a large consumer packaged goods client that we worked with, and it took 5 months just for them to get access to their data because they were trying to talk to the data team and they were getting roadblocks and they weren't able to get the data. Well, that can derail your projects. And then other organizations, it's not uncommon for it to take 12, 18 months for one iteration. That is not agile. That is really predictive, right? That's a waterfall approach, and that's way too long to get one iteration out. So that's why CPMAI was developed. And then as far as the data, well, it depends on what you're doing with your project and also how fast your data is going to be changing as to whether or not you can use the same data or if you're going to have to get different data.
Yeah, and I also look at it as capability. I mean, a process has to have a certain capability, like Six Sigma. And if it's not repeatable, then it's kind of hard to design a process around it, or even an AI system around that because it never does the same thing every time. So if the process is not repeatable, then it adds a lot more complexity to the whole problem. And so
Exactly.
and
And
so
it
I
needs
always look at repeatable processes first.
Yeah, and I really like that point too. The other thing that we have that comes with the training and certification is a workbook. So we have a series of questions that you should be asking at each phase of the project, and then you can document it so that if somebody leaves the organization or if somebody joins the organization or if somebody leaves the project or joins the project, they're able to see how the project is progressing. And now that I've been working at a large organization, I tremendously understand the value of that. Not everybody likes to have too much documentation, but some documentation is always good.
There's one more about security. Is it keeping up with AI technology? Is security progressing with evolving AI technologies?
Okay, yeah, that's a great question too. We get asked a lot about security, about cybersecurity, and AI is evolving so rapidly, right? And security is always a big issue. And so if I think about it from that cybersecurity lens, or even with banks and fraud detection, how I brought that up, it really is hard. And so we have to make sure this is why it's really important to also involve different teams with this and make sure that you are addressing these challenges, understand what the needs are at your organization, and then you want to make sure that these systems that you're using are also secure. And so, you could take this question from a few different angles. So as you're bringing AI technologies into your organization, are they going to be secure? And will your organization be able to treat it in that kind of way? Lots of organizations have data security issues, concerns. And you just need to be asking the right questions. And I always say, learn from others. That's even what I'm doing. Because if my organization has security challenges, I'm sure other organizations are having them as well. So how have they worked, to address those challenges and make sure that things actually are secure? And it might look a little bit different depending on the tool, depending on if it's going to be in a closed environment so that no data is being sent out to retrain these systems. That's usually where more organizations feel comfortable.
Okay. Anything else in the chat? I don't see anything. Okay, so just for the PDU code, everyone can use the PDU code. I mean, I'll even take feedback from all of you if you want to send us feedback. But yeah, the PDU code can be used by everyone. It doesn't really matter which chapter you're from. Any other questions before we go? This was a great session, Kathleen. A lot there, and we will make sure you guys get the slide, and the recording will be available too, all that good stuff. All right, if there are no other questions,
I got one.
guys, oh, one more. There
Yeah,
you go.
Hi, great show, Kathleen. Thank you so much. I can't help thinking that, like for the airline example with the briefing policy, if the data had been more carefully curated or shaped, would that have mitigated that kind of behavior?
Yes. And really, it's hard when you put a chatbot out there and have no guardrails in place and say, be able to ask any and every question that you want. And you have to try and test for it before it gets put out there. So that's always why I say, try and narrow what you're doing. So figure out what problem you're trying to solve, because it might have not actually been to find bereavement policy. Maybe they wanted the chatbot because they wanted customers to have an easier time of figuring out if their flights were going to be delayed or figuring out what gate they were supposed to be at. But they just let the chatbot out into the wild, and it was supposed to answer any and every question that customers threw at it. Well, when you set that up, people are going to be asking any and every question. If you provide guardrails and say, we have a chatbot and it's going to be able to answer this set of questions or areas in, this domain, then you don't need as much data and you can really test what's going on. And so that's usually what I say to do. What data was that trained on? I don't know. How well was it tested even before it went out? I don't know that either. So that's why it's really important to make sure that you kind of put those, guardrails in place so everybody, including the end user, knows how and when and why they should be using this.
So maybe if it gets a question outside of its domain, it directs the customer to talk to customer service, for example.
Exactly. Exactly. Or say, this isn't a question that I can answer. I encourage you to go to the website, call customer service, take a different approach, so that you're still providing an answer to the customer. You're not saying, I don't know, but it's not necessarily giving them an answer that's not correct. Which at the end of the
Good
day,
to think about in
horrible.
hindsight, especially.
Kathleen,
about that.
Professor Kevin Riley here. What a great presentation. Thank you so much. And I really like the example of the supermarket. And my motto is there's no AI without HI. There's no artificial intelligence without human intelligence. So it's just important. As we all know, a lot of people are getting very scared and panicking about AI, but jobs may go away, but it's just like when the internet came out, just like the industrial revolution, we have to upskill and reskill. So it's wonderful. So thank you very much for a great presentation. Appreciate it.
Thank you.
Thank you.
Last call for questions.
Yeah, I like the example you use of the supermarket. I agree with you on that, Kevin. It's, aisle by aisle, start that way. And then work. And if you want to do the whole store, that's different than starting out with just one aisle.
Love it. Well, I don't have anything else for you all. So like I said earlier, check us out. We have things out on our calendar. I'm sure Phoenix does as well. Southern Nevada. Just keep up with what we're up to as chapters. And let's do this again next month and for the rest of the year even. Have a great one. And thank you again, Kathleen, for this amazing presentation and giving us your time. Totally appreciate that. All
Yeah,
right.
thank
you.
you.
Have a great one, everyone.